Okay, so our first thing is to figure out how we're going to do the derivative of a product. When I say product, I mean things being multiplied together. Now, sometimes it's no big deal. If I had something, if I, just had two binomials, all we were doing before is multiplying them out, and then we could do our derivative. And that is certainly still an option, and a lot of times the easiest option. But if you have some really big things, that may not always work. So we need another route to take. So what we're going to do is branch into this product rule. So it looks kind of complicated. I can try to decide if I want to, do you want me to show you where it comes from, or do you just want to take my word for it? You gonna take my word for it on this one? I was going to show you the why, but it's a little more involved than some of the other whys I've shown you, so it may not be worth our time. If you have the derivative of two things being multiplied together, essentially what we will do is one derivative at a time. Okay, an easier way of seeing it than this would be f times g prime plus f prime times g. So we will do the derivative of one piece and the other one doesn't change, and then we will add them together. So if we had three things being multiplied, we would extend this and we would have three terms in our final answer. We would do the derivative of the first one, the other two would stay the same. Plus, then we do the derivative of the middle one, and the other two stay the same. Plus, then you do the derivative of the last one, and the other two stay the same. So in the product rule, you do one derivative at a time, nothing else changes, and then you multiply those together. So let's take a look. Okay, if I gave you this problem. Last week, you would have just multiplied it out. And with this problem, that's probably still a pretty easy route to take. So in general, I wouldn't care. But I'm asking you to do it this time without multiplying it out. So we have to do our product. So my f and g, those are just like my two prints, the two things that we are multiplying together. And I just got done telling you, you do one derivative at a time. It really doesn't matter which one you do first, because we're just going to add them together, and when you're adding, order doesn't matter. So when we start looking at these, sometimes our answers might look different and still be equivalent depending on what route we took. So for this derivative, let's start with this one. If I did the derivative of that parenthesis, what do we get? Remember, the derivative of the 1 is a 0, minus 3 comes down, 4 times 3 is 12, subtract 1 from the power. Then the second parenthesis doesn't change. Plus, now the first one doesn't change, and you do the derivative of the second one. So what's the derivative of 3x squared minus 5x plus 2? We will talk a lot about how much to simplify our answers. This is one, it's not going to be a lot of work, so let's go ahead and multiply this out and simplify it as much as we can at this point. Before I move on, does everybody understand what happened here? So I did the derivative of the first parenthesis, second one stayed the same, plus the first times the derivative of the second. So one derivative at a time. So if I wanted to clean up my answer, if I distributed this, we get -36x to the 4 plus 60x cubed minus 24x squared. Over here you would have to FOIL. So you get 6x minus 5 minus 24x to the 4th plus 20x cubed. Add like terms, so negative 36x to the 4th and negative 24x to the 4th is negative 60x to the 4th, 60x cubed and 20x cubed, 80x cubed, and 24x squared, plus 6x minus 5. Okay, you would get the exact same thing if you distributed at the very beginning of this problem and then did the derivative of each term. Sometimes, though, the product rule is unavoidable. So sometimes it's not necessary. We could have done this one another way. But sometimes you can't avoid it. The product rule is the only way to do the problem. So I'd like to look at an example of that. Alright, so on this one, my function is x e to the x. This is a product. It is different than having something like 2e to the x, because I have the x in two different spots. I have an x here and I have an x in my power. That's what makes it a product rule, when you have that variable in both parts. We can't just combine x and e to the x and get it into just one x. So the product rule is unavoidable here. So when we work through it, we do this derivative. Derivative of the first. So my first is like my x here. Derivative of x is 1 times the second, which is just e to the x, plus the first, which is x, times the derivative of the second. What is the derivative of e to the x? E. About last week where e to a power, it didn't change. So this turns into e to the x plus x e to the x. So part B, I want the nth derivative. I'm asking you to find a formula for this derivative. So we've done the first one. Let's work out the second one. So my second derivative is just the derivative of our first. So what is the derivative of e to the x? E to the x. Plus, how do we do the derivative of x e to the x? Yeah, isn't that what we did first? The derivative of x e to the x, we have to do the product rule. So this is just for my derivative of e to the x. And then we have to come down to the derivative of this thing. So if you did product rule, derivative of the first times the second plus the first times the derivative of the second, and derivative of e to the x is still e to the x. So we get e to the x plus e to the x, which is 2 e to the x plus x e to the x. Do you guys see what happened? Want to do the third derivative, see if we can find the pattern? I'm asking you to find the pattern for the nth derivative. Let's see if that works. So what's the derivative of 2 e to the x? Just still 2 e to the x. Coefficient just comes along, and the derivative of e to the x is still the same. Then the derivative of x e to the x, we've worked that out twice now. That's just our product rule. The first times the derivative of first, derivative of the first times the second, first times the derivative of the second. 2e to the x plus e to the x is 3e to the x plus x e to the x. So, what would the nth derivative be? The first derivative was 1 e to the x plus x e to the x. Second derivative was 2 e to the x plus x e to the x. Third derivative is 3 e to the x plus x e to the x. So the nth derivative would be perfect. Basically, we just add another e to the x in each time. Alright, so far so good? Let's look at example 3. Okay, so what are the two different options for this problem? FOIL or product rule. Which one is probably easier here? Probably foiling, since there's only 2 terms in each parentheses, that wouldn't be a big deal. Since we're learning product rule, can I do it that way to practice? But know that, in general, I'm not going to care how you do it, as long as you can get the derivative. It would be beneficial, instead of a square root, we write that as x to the half power. Okay. So, the derivative. We do the derivative of the first, so derivative of 3x plus 1 is 3 times the second plus the first, so that was my 3x plus 1, times the derivative of the second. So the derivative of this would be what? 1 plus now this one probably didn't save us much time because now we have to go ahead and multiply it out anyway, don't we? So it would have definitely been faster to FOIL first, but we're practicing this technique. So we get 3x plus 3x to the 1/2. Alright, if I FOIL over here, we get 3x plus, when you multiply these, you get 3/2. This is x to the first, you add exponents, so 1 plus -1/2 is 1/2. Plus 1 plus 1/2 x to the -1/2. Then we add like terms. So 3x is 6x. 3x to 1/2 and 3/2 x to the 1/2. So 3 is like 6 over 2 plus 3 over 2 is 9 over 2. So good. I think I'm going to skip example 4 for now, and I want to go to example 5. Okay. So f of x is the square root of x times g of x. But I'm not telling you what function g is. I'm just giving you some information. G of 4 equals 2 and g prime of 4 equals 3. And I want f prime of 4. So I'm asking a lot right now. my function is the square root of x, so x to the 1/2, times whatever function g is. So if we do this derivative, you do the derivative of the first, so derivative of x to the 1/2 would be what?
1/2 x
Times the second, plus the first one, so x to the 1/2, times the derivative of the second, so that would be g prime. So that's all I can work out so far, but I'm asking you to find f prime of 4. So if I plug a4 in this, four to the negative 1/2. So a negative power puts it on the bottom, right? A 1/2 is like a square root, so that's like 1 over the square root of 4. What's the square root of 4? So we have 1/2 times 1/2, which is 1/4. Times g prime of, or sorry, g of 4. And I told you that g of 4 was 2. Plus 4 to the 1/2 just means the square root of 4, which is 2, times g prime of 4, which is 3. So 1/4 times 2 would be 1/2, plus 6, we get 6.5. So this one we had no choice but to use the product rule because I didn't give you the actual function. I just gave you the information and kind of required you to take this route. All right. So that's the product rule. Let's talk about the quotient rule. So quotient rule comes when you have two things being divided. Okay, this thing looks kind of nasty. What it says is g times f prime minus f times g prime over g squared. Okay, f is the numerator, g is the denominator. So it's the bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. Unlike product rule where you could flip the order, because this stuff is subtracted, order does really matter here. A lot of times you will hear me say, my little trick, I say low, D high, minus high, D low, over low squared. Low meaning the bottom, D high, derivative of the top, minus high D low, the top, times the derivative of the bottom, over low squared, over the bottom squared. So let's look at some examples. So d sub x, that's just another notation saying derivative. This is a problem where you probably wouldn't want to use the quotient rule. It would be a lot easier just to go through and divide each of these things by 2 over x squared. You know, if we did, that's the way we would have done it last week. We would have had 5 halves x squared minus 3 x over x squared be x to the negative 1 plus 7 halves x to the negative 2. And then when you did the derivative of this, the 2 comes down, so you get 5x plus 3x to the negative 2 minus 7x to the negative 3. And that would be much, much faster. Let's do our quotient rule and see if we get the same thing. Okay. So quotient rule says low, so that's the bottom, d high, derivative of the top. So what's the derivative of the top?
X to the third minus 6x.
The x would become just a 1, so, and the 7 would go to a 0. So there's low d high minus high d low. So high, the top, d low, derivative of the bottom would be 4x over low, so the bottom, squared. So if we clean this up, we distribute, we get 40x to the 5th minus 12x squared minus, so we got 4x on the bottom, 2x squared squared be 4x to the 4th. So if we clean this up, we would have to distribute this negative. So 40 minus 20 is 20x to the 5th. Negative 12x squared and positive 24x squared is 24x squared minus 28x over 4x to the 4th. What could you do to all of these? Everything here is divisible by a 4, and we could also cancel out an x. So if I take a 4x out of everything, we get 5x to the 4th plus 6x minus 7 over x to the 3rd. Now this is written a little bit differently than the other way, but are these things equivalent? 5x to the 4th over x cubed is 5x. 6x over x squared. Oh, hold on. Oh, I did.
Yeah.
Yeah. Thank you. See, you guys have to catch my mistakes.
I saw that in the first.
Negative 12 plus 24 was 12. Did I say 12 and write 24?
You said 24 still.
I said 24. Okay. Sorry. See, I did it 2 ways just so I could catch my mistake, guys. So 3x over x cubed is the same as 3x to the negative 2. 7 over x to the 3rd is 7x to the negative 3. So what I'm trying to show you here is we're getting to the point in the class where depending on which route you take to do a problem, your answers might look different but still be equivalent. Okay, I would accept either one of these answers. They're both the same. Alright, this was definitely a scenario where it was a lot faster to simplify first. And in general, if you can simplify before doing the derivative, do so. It'll make your life easier. But sometimes you can't, so then we have to go this route. I'd like to do maybe one more of these and then we'll probably stop there for today. So is this one where I could simplify first? We could only divide them if it was only one term on the bottom, right? Since I have 2 terms, The only way to divide this would be long division, and that's not going to make it better. So this is not a scenario where we could simplify first. This is a scenario where we would have to use the quotient rule. There's no other way. So we're doing quotient because we have things divided. So quotient rule is low, so the bottom. D high, derivative of the top, is 2x plus 1, minus high, so the top, D low, derivative of the bottom is over low, so the bottom, squared. Okay. Simplifying on the top, if we FOILed here, we get 2x to the 4th plus x cubed, 12x plus 6. Would it confuse you if I distribute my negative and my 3x squared at the same time? It becomes a negative 3x to the 4th minus 3x cubed plus 6x squared. The bottom, you could FOIL this out. I am not going to. I'm just going to leave it as x cubed plus 6 squared. So combining like terms. So we have a 2x to the 4th and a negative 3x to the 4th, so that would be a negative x to the 4th. We have an x cubed. We have an 6x squared. You can put these in any order. I'm doing decreasing order, but you don't have to. Plus a 12x plus a 6. So this is one where we didn't really have another option. We would have to go this route. I have a mistake. I didn't combine my x cubes, did I?
Yeah.
Sorry, it's not my day. X cubed and negative 3x cubed would be negative 2x cubed. What we're going to do is stop here for today. We'll work on this more tomorrow. For today, I have